Hey mathletes, what we're going to talk about in this video is the definite integral. What we've been learning up until this point is different methods to integrate things. So we can integrate the basic power law, we can integrate using by parts and by substitution, which helps us when we've got product rule and when we've got chain rule. So what we're going to do in this lesson is we're going to look at the definite integral and combine it with these previous skills. What a definite integral is simply that now we're going to have something known as bounds, and we're going to be able to evaluate the integral. Again, we've talked about this a few times. The whole reason why we're looking at integrals is it's going to help us find areas and volumes. So that's where these bounds are going to come in. So the bounds I'm talking about here are these A's and these B's. So just like that. So what these bounds are going to be is it's going to be our lower and upper bounds, what they're going to be called. As these will end up being X values most of the time for us. And what we've been doing is when we've been taking the integral or the antiderivative, we write it as capital F at X. But now what we're going to do is we are going to evaluate. So we're going to put this straight line up and down. And what this says is we're going to take the antiderivative, which we did, we got F at X, and now we're going to evaluate it at B and at A, whatever these values are. And as the B is the larger value and A is the smaller value, and we're going to be finding an area or a volume, what we're going to do is we're going to take the function at our larger value minus the function at our lower value. Now, the one thing to note here, we don't need the constant of integration, the plus c, because as we're subtracting these two values, the plus c would end up going to 0. It would cancel out. So just something to note the difference between when we need that plus c, that constant of integration or not. Okay, let's see what we do here. So determine the value of the following definite integrals. So again, we'd be finding an area under a curve here. So just to give you a brief picture of what that means, is here's x squared, roughly, right? And it says my lower bound or our lower bound is 0 and our higher bound is 1. So what we're actually finding when we're doing this, friends, is we're finding that area right there. So just to give you some more context as to what we're doing. Okay, here we go. So first thing we do, we take the antiderivative, so add 1 to the power, divide by it. We don't need the plus c because we're finding the definite integral. And now, friends, all we do is we sub in our values, just like this. And what you can see right off the bat is the value of this will be 1/3. So again, what that really is telling you is that this area under here is 1/3 units squared. Pretty cool, hey? Okay, now what I want you to do here is here's definitely a more complicated looking integral. What I want you to do is I want you to hit pause on the video. I want you to simply try to integrate this first, just like you've been doing in the last few lessons, and figure that out. That's the more difficult part. The definite integral part is not the difficult part. Okay, so please hit pause. I want you to see if you can sit and think about how you're going to integrate this nasty looking beast. Good luck. Okay, friends, I hope you took a moment to try to figure out how you could attack this thing. I think to me, it's a little more clear. I'm going to rewrite this definite integral. I'm going to rewrite it like this. And then this is x to the -2 dx. All right, to me, as soon as I do that, maybe what I'm going to see here, actually, you know what, I'm going to rewrite this even just a touch better. I don't know if it's better, but it makes it more clear. What I'm noticing, again, the first thing I'm always going to try in a complex function like this is substitution. And what I'm noticing is this, that the derivative of that is going to, I believe, give me that. So that's what I'm going to check. So again, with substitution, the nice thing is, friends, you try one way. If it doesn't work, you try the other function to do the substitution on. And if it doesn't work, well, then you got to try something else. Okay, so the derivative of u, then I take the derivative of this guy over here, and then with dx. Okay, perfect. Look at that's what I see on the other side. I'm just going to divide both sides by -1, or you could also think of that as rearranging. And so there it is. So now what we're going to do is we're going to perform this substitution. So here we go. And so we perform that substitution. So we get u squared, and then it'll be negative, and then du. Okay, but now friends, all of a sudden this function went from x's to u's, and our bounds are in terms of x. So in fact, what I'm going to do here is I'm actually going to remove these bounds for a minute. Now, we could, in fact, friends, figure out what those are in terms of u by using this. Okay, I'm not going to. For a second, what I'm going to do here is I'm just going to go and calculate the integral, and then I'm going to resubstitute back in. Okay, so take the antiderivative, like that. Okay, again, I don't know my bounds at this moment. I don't know my bounds. I could figure those out in terms of u. I'm just going to be a little lazy, but that is a different approach. Okay. And then what I'm going to do is I'm going to resubstitute back in. So what we said u was x to the minus 1 minus 2. And now our bounds were from 1 to 2. And so now, friends, all we do at this point is we're going to substitute in. Oops, I lost my cube there. My apologies. And now all we do is we really carefully, I see a lot of mistakes here with students when they're doing these things, is just take our time and just simplify this thing down. Notice how I'm putting brackets around everything, because I don't want to make a silly little mistake, right, when I'm substituting in values like this. Okay, and so there we go. And so we substitute in those values. And again, the mistake I'll see quite often is with this negative right here. Okay, is that students will mess that up right in there. Okay, and friends, after that, all we've got to do is just substitute this in, calculate it, and we get our answer. And at the end of this one, I don't know, what are we going to get here? So we're going to get negative 1/3. That's a half minus 2 cubed. And then here, we're going to get negative 1/3, 1 minus 2 cubed. And, you know, maybe at this point, I'd be inclined to just pick up my calculator and to figure out what the value of this is. Okay. And so at the end of this, friends, you're going to get a value of 19/24. All right, let's try another one. We'll do 2 more. Next one. Ooh, look at that nasty one. Okay, so same as last time, hit pause. I want you to think about how you're going to integrate that beast on its own. Okay, friends, let's see what you came up with here. What I'm noticing is that the exponent on the e actually looks like it's going to give us a nice substitution. So I'm going to say, let's let u be that. Then du is 4x cubed plus 2x dx, just like that. And then what I'm going to notice, I've almost got that term out front, right? So I'm going to factor out a 2. So 2x cubed plus x dx. Now it's looking good, isn't it? So I'm just going to divide both sides by 2. So 1/2 du is equal to exactly what we're looking for, aren't we? Okay, so we go and we do that substitution. And so again, I don't know my bounds at this point. So you just got to be careful about that you're using the correct bounds as you're going through these things, right? Okay, so let's substitute that in. So we said what we're going to get is, now we've got 2x cubed plus x. We called this e to the u, and dx is 1/2 du. Oops, I'm also going to divide by 2x cubed plus x, like that, right? I should have done that right here. Sorry, my friends, my coffee has not kicked in on this chilly morning yet, like that. And now my functions divide out right here. So I'm in good shape because now I'm all in terms of u. And now what have I got, or what do we have? We don't know those bounds. I'm just going to simplify this down a little bit. All right, look at that. We got ourselves a nice, easy function to take the antiderivative or the integral of. So we take the antiderivative of that. Well, again, the antiderivative of e to the u is just going to be e to the u. Question mark, question mark. And now we're in terms of x. Let's sub that back in. What did we say x was? This nasty thing. It was x to the 4 plus x squared, right? And then our bounds are 0 to 2, just like that. And now, friends, what we can again do is just sub in these values. And what we're going to get, 1/2 e to the 2 to the 4, right? Nasty looking, right? Like this, like what the heck is this function? Minus 1/2 e to the, well, this will make life easy, 0 to the 4 plus 0 squared. All right, what do we get here? 1/2. I could have factored that half out of the whole thing if you really wanted me to. Again, there's different ways to get that. It's going to be 16 plus 4. That sounds like 20. Over here, well, e to the power 0 is just going to be 1. So it's just going to be minus a half, as Mama would say. And like I said, we could have factored that half out right at the beginning, and we would get e to the 20 minus 1. There it is. All right. And again, I just want to mention, just to be really clear, if I wanted to at this moment, I could have found these bounds in terms of u by substituting in my two x values into my substitution. And then I could have then calculated my definite integral rate from here. Okay, so there's two different ways to approach it. It's really up to you, friends. I like to stick with x's. It's one less thing for me to do, but sometimes finding the bounds in terms of u is a touch easier. All right, friends. One more time into the breach. Hit pause. Tell me how you're going to integrate x cos x. See you in a moment. Okay, friends. So again, the first thing I would try is just, can I take the antiderivative? No, can do. Then I try substitution. Well, if I substitute for u or cos x, it's not going to help me take care of the other function. So then kind of going down my pathway, it's going to be by parts then. So let's try by parts. And again, when we're doing these ones, what I'm going to say is my easier function that differentiates to 0 is what I'm going to call u. So I'm going to let u be x, and then therefore du is equal to 1 dx. And then what I'm going to say is dv then is my other function, so cos x dx. And the nice thing here is when I take the antiderivative of that to just get v, I know the antiderivative of cosine is just sine x. Okay, and so by parts. And so remember how this goes. Our formula for by parts is the integral of u dv is equal to uv minus the integral of v du. And then all we've got to do is substitute in our values here. So uv minus the integral from, and again, 0 to pi half of v sine x and du, which is dx. Okay, and again, I know I'm doing this correctly because look at that, integral is something I can calculate the value of. So now what I'm going to do is x sine x, and here's this definite integral. I'm going to put that in big square brackets like that, friends. Okay, and so the antiderivative of sine is negative cos x, pi half to 0, just like that. And now what we're able to do from here is to start finding, we need to evaluate this whole thing right there, just like that. And right here, friends, as well, what we're also going to need to do is we're actually going to evaluate the whole piece, this whole thing. So I'm going to actually change where I put my brackets, friends. We're going to change, my apologies. We're going to find the entire thing like this. There we go. Okay, and so now what we can do is now go ahead and find the value of this at pi half and add 0. Okay, so here we go. Let's sub in those values, and here's where we got to go back and use that unit circle, right? So what we're going to get is we're going to get pi half sine pi half. This will end up being a plus in here, right? Because a negative and a negative, plus cos at pi half minus, and we do the whole thing again, but with x being 0, which will make our life a little bit easier, won't it? All right. Sine at pi half is 1. If you remember your unit circle, not a bad thing to maybe draw out. Cos at pi half is 0, so that makes our life easier. And then this back term here, well, that first one's obviously going to be 0, and cos at 0 is actually 1, if you remember that. And so now what are we going to end up with? We simply end up with pi half minus 1, and there it is. Okay, friends, I hope that helped finding definite integrals.